Shaft couplings are devices which are used to connect two shafts together. Shafts need to be connected for two primary reasons. First, to transmit rotary power, and second, to extend one shaft by the addition of a second one. When a coupling is used to extend a shaft, the objective is to make the two shafts perform as one. Rigid couplings, such as are seen here, are used where it's desirable to have two shafts act like one. Shafts of different diameters may be connected with certain types of rigid couplings. When a rigid coupling is used, in effect, there is only one shaft. Bearings should be placed as close to the couplings as possible. Bearing and shaft alignment in this application is critical. Rigid couplings are fairly uncommon this day and age. They were used extensively in the past, and a professional power transmission person should be aware of them. Flexible couplings are the modern way to transmit rotary power. They get their name from the fact that when two shafts are connected with one of them, the connection is not totally rigid. The flexible coupling allows some degree of misalignment in the relationship of the two shafts. Where the rigid couplings require nearly perfect alignment, a good flexible coupling is designed to permit less than perfect conditions. Most generally, the two shafts that must be connected are the drive shaft from the prime mover and the input shaft of a machine. These two shafts are called the driver and the driven. Often, when these two shafts must be connected, many problems exist. The driver and the machine may be large and hard to move. These machines may be mounted on different bases, which may shift in relation to one another. The shafts in these machines may shift endwise during production processes. Vibration and shock loads may be transmitted from one shaft to the other. The surroundings may be hot, cold, wet, or dry. Flexible couplings should accommodate these conditions. Angular misalignment is where the two shafts are not exactly pointing in the same direction, like this. Parallel misalignment is where the two shafts point in the same direction, but are not centered one with the other, like this. End float is where the distance between the connecting shafts changes. End float can be ever-changing and can present an engineering challenge. This shaft may move over and push on that shaft. If the pressure is carried through the coupling, this action will put extra load on the bearings supporting the connecting shaft. The bearings in the original shaft were probably designed to take this load. When the load is transferred to the other shaft, those bearings may fail if they've not been designed to accommodate thrust loads. Other damage may occur as a result of end float. A coupling that can change in length while running can prevent this load transfer. Shock and vibration may be passed from one machine to the other. These are destructive elements, putting stress on mechanical components. A flexible coupling, which has the ability to dampen shock and vibration, helps protect equipment. Flexible couplings are manufactured in many styles with a great variety of engineering concepts. No one style offers the best solution and cost for all applications. For purposes of this lesson, flexible couplings will be divided into two groups. One, all-metal mechanical flexible couplings, and two, elastomeric flexible couplings. A non-metallic elastic part is fastened, bonded, or gripped in some fashion and used as a flexible element in this style. The all-metal flexible coupling gains its flexibility by allowing the coupling components to slide or move relative to each other. Four common types are the chain coupling. It consists of two sprockets with a piece of double chain wrapping them. Shaft misalignment is accommodated by clearances that exist between the chain and the sprocket teeth, and clearances in the chain itself. A cover may be installed over this assembly. Gear couplings. Here, hubs with gear teeth on the outside are surrounded by a 1- or 2-piece coupling body called a sleeve. The sleeve has internal gear teeth. Here, the tooth profiles of the hub teeth and the sleeve gear accommodates misalignment between the two parts. This coupling must be lubricated. Grid couplings. These hubs are machined to accept this center member called a grid. The grid flexes between the hubs and allows the hubs to be out of alignment. The grid also dampens vibration passing from one shaft to the other. A cover and lubricant must be used. Another popular all-metal coupling is the flexible disc. These discs are used in stacks or packs, as they are called. The steel discs are used in both single and double series, as you see here. This is the first all-metal coupling that has been demonstrated which does not require lubrication. There are many other metal types of couplings, such as the spring coupling, the metal spider, the silent chain coupling, and so on. No other power transmission product offers so many varieties of design as shaft couplings. Chain, gear, grid, and disc pack styles make up the vast majority of the all-steel flexible coupling. Power transmission specialists come in contact with these 4 types on a regular basis. The elastomeric style of couplings are those with a non-metallic member of some style or shape. Here is the jaw type coupling. This part is called the spider. The spider fits between the 2 jaw hubs like this. Spiders are made from various materials. As can be seen, the 2 halves flex in relation to each other. If soft material is used for the spider, the coupling has the ability to dampen vibration and shock. This coupling's center member has teeth molded on the edges. The internal teeth in the hubs grip the element. Flexibility is gained from the 3-piece construction. The material of the center element has substantial effect on the coupling performance. Here, the center member looks like a tire. Flanges on the hubs grip the rims of the tire. This affords great flexibility. This coupling makes use of a similar element. Here, the tire is turned inside out. This coupling has elastomeric material bonded to sleeves, which bolt onto the hubs. The elastomeric elements of these couplings are easily replaced. Here, bolts from each shaft flange go through the steel bushings inside the individual rubber elements of this metal center member. Misalignment and shock load are again accommodated by elastomeric material. Shaft couplings often have auxiliary features to provide additional functions as well as their basic one. Couplings can be designed to slip at overload. This coupling has a spring-loaded clutch of friction material as an integral part of one hub. The amount of torque transmitted through the coupling is adjustable. This coupling has one flange that bolts directly to the flywheel of an engine. A brake drum is part of this coupling. One device serves 2 purposes. Another example of one unit serving 2 purposes is this soft start device. It has, as an integral part of it, a shaft coupling. Couplings that are extra long are called spacer couplings. The main use for spacer couplings is on centrifugal pump applications. By dropping out the spacer part of the coupling, there is now room to remove the pump face. Inspection and repair may now be done. The hubs of the spacer coupling were left in place. No realignment or moving of the equipment is required for servicing because of the spacer coupling design. Where even more room is desired or necessary between shafts, this arrangement is convenient. It's two couplings with a shaft between them, called a floating shaft. The name floating shaft comes from the fact that there is no bearing support necessary. The shaft floats, so to speak, between the two couplings. One reason there are so many different styles and types of shaft couplings is because there are so many different types of conditions and requirements by industry. A review of this program indicates the following facts. The primary functions of shaft couplings are to transmit rotary power and to connect two shafts. Rigid couplings accomplish these functions, but proper shaft alignment is critical. Flexible couplings transmit torque and connect two shafts. In addition, they offer some misalignment capability. It's important that shafts be aligned properly for any type of shaft coupling. The ability of a coupling to accommodate misalignment should be reserved for unavoidable changes in the relationship of one shaft to the other. The two kinds of misalignment they accommodate are angular and parallel misalignment. Some flexible couplings have the capacity to dampen vibration and absorb shock, as well as accommodate limited end float. Flexible couplings are grouped into two principal categories, all metal and elastomeric. Common types of all metal shaft couplings are chain coupling, gear couplings, flexible grid, and flexible disc types. Common types of elastomeric couplings are the jaw type, where the elastomeric center member is contained by the two shaft hubs, with protruding lugs or jaws. The molded gear pattern type, where the center element is contained by two shaft flanges with mating gear patterns. This style with the tire type element contained by shaft flanges and clamping rings. This type with its center element also contained by shaft hubs and clamp ring. This type with the elastomeric element bonded to metal sleeves which bolt to the shaft hubs. And this type with the center member containing individual elastomeric elements connected by bolts to the shaft flanges. Some of the special purpose shaft couplings are designed to provide overload protection, connect directly to engine flywheels, and to provide an auxiliary brake drum. Spacer couplings permit driven equipment, such as centrifugal pumps, to be repaired with minimal disturbance of the driver and the piping connected to the pump. Floating shaft couplings connect the driver and the driven shafts when the gap between them is greater than normal. Chapter 7 of the PTDA Handbook contains additional information about these and other shaft couplings used by industry.